Hello guys, this is an introductory video to a new sequence of tutorials where we're going to be discussing how to factor quadratic expressions. In this first video, we're going to be checking out expressions that have 1 as the leading coefficient. To begin, we should check out the anatomy of a quadratic expression. Pretty much any quadratic expression that we want to factor, we will find it in this form. 3 terms: ax squared plus bx plus c. This first term, the one that has the x squared, we call it the leading term. Furthermore, the number that accompanies the x squared, we call it the leading coefficient. This name is important because there are 2 special cases. One, when a is equal to 1, and is the topic of this tutorial. Later on, we will be checking the second case, that is when a is different from 1. Finally, the last term of our quadratic expression, that we call c, is a constant term. And this guy is going to be the determinant to the way we factor these expressions. Let's check out our first example. X squared plus 7x plus 12. So we know that a quadratic expression can be factored into 2 parentheses, where the first 2 terms should multiply up to the first one. So 2 things that multiply to x squared, there's no other than x and x. Now, for the second terms of each parenthesis, we want to put numbers that multiply up to 12. But if you check out the factors of 12, there are several pairs that achieve that. You can think of 1 and 12, you can think of 2 and 6, and you can think of 3 and 4. Now, which of these 3 pairs should you choose to put down here in your parentheses? There's a small test that you can do just to determine that. Start adding them. So if you add 1 and 12, you obtain 13. If you add 2 and 6, you obtain 8. And if you add the third, 3 and 4, it would give you 7. Notice that this 7 is exactly this 7 that you have here in the middle. So these 2 terms that you found here are the numbers that should become part of your parentheses. Exactly with the same signs. Notice that the 2 of them were positive, so here I write positive 3 and positive 4. Now, why does this work? Pretty much because you know that this term in the middle is the product of the adding of 4x and 3x that are the products of these 2. So 4x plus 3x will be giving us 7x. That's why this guy works. Let's check out our second example, where in the constant term we have a negative number. Same thing, you want to build up 2 parentheses. Immediately you know that the first 2 terms in each one of them is x. Now, if you think about negative 18, there are many more factors because you need to consider positive and negative ones. So 1 and negative 18, 2 and negative 9, 3 and negative 6, 6 and negative 3, 9 and negative 2, 18 and negative 1. To determine which of these 6 pairs you have to use, you use exactly the same test. You want to obtain a 7. So if you start adding, you obtain negative 17, negative 7, almost. Just that this guy is negative 7 and one a positive 7, so it should continue. 3 minus 6 is negative 3, 6 minus 3 is positive 3, 9 plus negative 2 is 7, and 18 plus negative 1 is 17. So you see that the pair that gives you a positive 7 are 9 and negative 2. Once again, the numbers that you copy here go exactly with the signs that you found here in your factor table. That means you have one parenthesis that is plus 9 and another parenthesis that is negative 2. For our third example, I want us to check what happens when the constant term is positive, but the term in the middle is negative. So, as usual, we begin with our 2 parentheses, x at the beginning of both, and then let's check out the factors of 10. So you have 1 and 10, you have 2 and 5. And now let's perform our test. 1 plus 10 is 11, 2 plus 5 is 7, but we didn't achieve what we wanted. We want a negative 7, and this guy is a 7. That happens because as you see a negative sign here, you need to consider not only the positive factors of your constant term, but you should also consider the negative ones. So you should also consider -1 and -10, because -1 and -10 multiply up to 10, and when added, they give you a negative number. So if you add these two new pairs that we found, you obtain -11 and you obtain -7. So see that these two factors that you found here are the ones responsible of this quadratic expression. So x minus 2 and x minus 5. Pretty much a tip for this is that whenever you see a negative sign, either in the second or in the third terms of your quadratic expression, you always need to check out the negative factors of your constant term. As usual, thanks for watching, guys, and check out Factoring Quadratic Expressions Part 2 that is coming up next.